This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 88, a talk with ASU's Luminosity Lab about how they use simulation to design their lunar probes, and an update on the news and events in the world of Ansys. Welcome to our podcast. I'm Eric Miller, your host and one of the three owners here at PADT. We're still in strange times. This past Thursday, the CDC announced that fully vaccinated people can pretty much return to normal life with a few exceptions. So we're trying to see how that impacts us here and how it also impacts our customers. But our sales team is very excited to get back out and see those of you who are lucky enough to be a PADT customer and are vaccinated. At the same time, things are getting more difficult across Asia and not just India. And even Toronto is experiencing a surge right now. So we send our best wishes and thoughts to everyone. Even though things are getting a little bit better here in Arizona, it's still a really dangerous place out there. So regardless of where you are in your journey, our thoughts are with you, and if we can help in any way, let us know. This is episode 88 of our little podcast. It's been a while since we've checked in on the stats, so let's do that right now. After 87 episodes, and this is the statistics are from Friday earlier this week, we have had 27,525 downloads. That's about 316 per episode. It's a number we've kind of hovered around for quite some time. 51% of our listeners are in the U.S., and so it's the bulk of it, but everybody else is spread around the world. Number 2 is 9% in Germany, 4% in Canada. The UK has 3% and France 2%. In India, there's 2% of the downloaders. So, and there's a ton of other countries where people are listening in from. Our most popular episode is still our interview with Dr. John Swanson, the founder and original author of Ansys, and do check that out if you haven't heard it before. And our first episode is still number 2 on that list. So a lot of people checking out the podcast by listening to that first episode. I want to give a big thank you to our regular listeners. You can help us out by subscribing to the podcast through whatever podcasting tool you use. And please let others know about the All Things Ansys podcast. For our interview today, we have a special set of guests. The ASU Luminosity Lab is an outstanding organization at Arizona State University that does R&D for industry and the government, bringing together students and professors from across the campus. They do some amazing things there. But today, we're going to focus on one particular project for NASA's new lunar exploration program. I'll let our guests, Tyler Smith and Connor Nail, explain about the program and how they use simulation to get where they are today. Where's the little red dot? Come on. Team, there it goes. Team's a little slow, so we'll give it a little bit of silence here. I want to thank everybody for joining us today for another customer interview. I'm very happy to have 2 guests today from Arizona State University, and I'm going to let them explain who they are and their journey to the world of simulation, and then the project that they used Ansys on. Tyler, why don't you get started?
Yeah, thanks, Eric. So my name's Tyler Smith. I'm the director of the Luminosity Lab at Arizona State University. So Luminosity is a interdisciplinary research and development lab. We work on a lot of different things, ranging from robotics and autonomous systems to AI and analytics, from military and defense projects to sustainability and energy, and medical and consumer, kind of a wide range of projects. Today specifically, we're talking about a project called VELOS, which is a NASA project that we worked on over the past year. To give a little bit of background on how I sort of came into the world of simulation. So I actually, in my undergrad and master's program at ASU, I focused a lot in multi-physics and analysis, and actually worked at PADT as an intern, and then transitioned to full-time. So I actually got to work with Eric quite a bit before I went back and worked for ASU. So that was my background. So I have a deep-rooted knowledge in Ansys and using it for a lot of different use cases. And so, in our day-to-day work at Luminosity, whenever we have projects that we can use simulation on, we like to use it. And so this was a great example of a project where we use simulation, and we'll kind of get into that in a little bit. But I'm going to let Connor also jump in and kind of give a little bit of background.
Great.
Yeah, so my name's Connor. I'm a senior at ASU in mechanical engineering. and I just started my master's in robotics and autonomous systems. I started at the Luminosity Lab about a year and a half ago, and this was the first project I started working on with Tyler and the rest of the lab. And so I kind of got into simulation a few months before that during an internship I had at NXP, and I was designing pressure vessels and such and using simulation on those. And I hadn't used Ansys before until this project, and Tyler introduced me to that, and I've just been using that a lot ever since. Really enjoyed getting to use that. I find it interesting to be able to like simulate things mechanically. And so kind of just started doing that and applying that to VELOS and some other projects in the lab.
Very cool. And I'll interject a little bit here, a little bit off topic, but those of you who are listening that follow our newsletter and other publications that PADT does, the Luminosity Lab, I'll give them a little kudos here and shout out here. We're very instrumental in the state's response to COVID, especially when it came to PPEs and using 3D printing on PPEs. So I want to thank you guys for, we're gonna nerd out on Ansys, but before we do that, I want to thank you guys for the significant contribution you guys made to the effort.
Yeah, we're glad we could do whatever we could.
Yeah, it was important to have a coordinating group, and you guys did a great job of that. So anyway, let's talk about the project itself. Why don't you guys describe what the project was and what the goals were and what happened?
Yeah, I can give a little background and then let Connor kind of dive in on the simulation piece. So just to give some backstory, so NASA is working on the Artemis program, and the Artemis program is the mission to return to the moon. And so Apollo was the first mission to the moon, and everyone knows about that. And then Artemis is NASA's return to the moon with a crewed mission. So they've sent different probes and things like that, and they've sent orbiters and satellites, but this is the first crewed mission back to the moon. It'll be the first mission with women astronauts on board, and so they're going to have some of the first women on the moon as well, and that's going to be great. And they named it Artemis because Artemis is the twin sister of Apollo, and so there's a lot of symbolism that NASA uses in their naming convention. And so when we started this project, this was a competition called the NASA Big Idea Challenge. And so it's part of NASA's mission to go return to the moon. And in doing so, they've identified a number of different challenges that they know they need to overcome in order to go back. And so some of those are related to dust mitigation, which they found to be a big problem in the Apollo mission, to extreme environment exploration, to power and things like that. And so there's a number of these different challenges, and this specific one was related to extreme environment exploration. And so our team put together a concept for exploring the site that NASA is going to be returning to, called which they are titling the permanently shadowed regions. And this is on the south pole of the moon. In the craters on the south pole, there are regions that are permanently shadowed, and they're permanently shadowed because like Earth, how the poles of Earth, the sun doesn't go directly overhead, and so the sun is always on the horizon or below the horizon. And in these craters on the South Pole, there's actually regions that have been permanently shadowed, and so they know that, or they expect that there is ice in these regions, and they want to go explore that region for the purpose of being able to, one, identify if there is ice there, and two, if there is ice, they can use that to collect and then generate, from ice, you can, this is water ice, by the way, they can generate water for habitation, but more importantly, probably they can also generate rocket fuel because they can break it down into hydrogen and oxygen. And so this is critical for a sustained operation on the moon. And so to do that, they're going to go on one of the early missions and explore these permanently shadowed regions. And to do that, they need systems that can explore them. And so it's this very extreme environment. It's very, very cold. It's dark because it's permanently shadowed, so solar power doesn't work there. And so they put this call out for ideas for how to solve this problem, and that's what our team responded to with a solution for exploration. And so our concept that the team developed to explore these regions was to launch sensor probes from the lander. So it was given that a lander would be landing within 100 meters of the permanently shadowed region. And our system is designed to launch sensor probes from the lander into the permanently shadowed regions over 100 meters. And so these sensor probes would be able to be launched and then they would they would collect data and then wirelessly transmit that back to the lander. And so this project we called VELOS, which is a Variable Exploratory Lunar Observation System, but it also has a dual meaning, like NASA, with their Artemis mission. So the weapon of Artemis, the Greek goddess, was actually a bow and arrow, and VELOS is arrow in Greek. And so our system, which is a projectile, right, we're launching it, has that kind of projectile behavior, much like the weapon of Artemis. And so a lot of cool symbolism. Our team came up with that name, and we're pretty excited about it. And so we submitted to that call for proposals, and our team was selected, awarded the funding to develop it. And so over the past year, basically over 2020 or over quarantine, our team developed it. And so when we first submitted that, we actually did preliminary simulation. So we did Ansys thermal analysis because we knew that these extreme cold environments, thermal analysis was going to be very critical. This is one of the coldest places actually in our solar system. So the temperatures in the permanently shadowed region is around 35 Kelvin, which is actually colder than the surface of Pluto. And so it's extremely cold there. And so we knew that this was going to be critical. So when we did before we actually won the proposal, we did preliminary simulation, put that into a proposal. They really liked the work that we did prior to the actually, winning the award. And we did that in order to demonstrate the capability to analyze the probes that would be going into this region. And then once we got into the project, we won the project, and we got into working on it. About 2 months into it, that's when everything shut down, went into quarantine. And at that point, we were already intending on using a lot of simulation, but at that point, our team really doubled down on the simulation that we were using, because we knew that we would have less access to testing, less access to labs. Facilities were being closed down that we were planning on using, all that kind of thing. And so we really doubled down on what we were simulating. And so I'll let Connor talk a little bit about that in more detail.
Very cool. Yeah, please let us know where simulation played a role in all this, and how it helped you, because you couldn't do physical testing, especially.
Yeah, we did quite a few different types of simulation. The biggest one, like Tyler was saying, was thermal, because of just making sure that our probes could survive. Like, it was very critical that they could survive a long enough time to be able to transfer whatever data we collected back. And so we had to validate that. And so we did that with thermal simulation, and we did that to iterate both for designing and for verifying. Like, we did many different iterations on the probes. I remember even at one point we had the electronics suspended on like cables and like different things like that, just to any way we could isolate it, to make sure that heat stayed inside long enough. And it was also really helpful for validating. We were able to get into a towards the end, a testing facility to get test our prototype that we had built. And honestly, one of my favorite parts was seeing that data we collected on that physical prototype and that testing, seeing that data come back and then comparing that to the model and watching like how accurate it was to it. And that was super helpful as well, because we were able to take that validated model and expand that to what it would be like in more accurate like environment, closer to the permanently shadowed regions. So much colder and under complete vacuum. So that was kind of like the main, like that was one of the biggest applications of the simulations we did, was the thermal aspect of it. And we did that as well on the, what's it called? The launcher, the system that would launch the probe. But then like the bigger aspect of the launcher was the structural side of it. And so that we had to make sure that would be a couple things, that it wouldn't impart too much of an impulse on the lander itself. Like there could be other equipment on there that requires like stability and stuff like that. So it was simulation. We were able to test that without having to, set up any fancy equipment or anything for our physical prototypes. It made it much easier to really determine that we would be within those limitations that the landers would have. And then as well, the launch from Earth. Because during that launch, there's lots of vibrations, right? And the whole system's going to undergo quite the ride. And so we were able to simulate that through a random vibration analysis. And so that was also really eye-opening. We were able to identify actually some parts of the design that we thought would be fine. But then after doing the simulation, we identified a few parts that we were going to have to beef up a little bit because they were bending or such. It would, or at least they would, under that experience as it launched in the rocket. And then the other one we did that was also a big one was the drop testing of the probes. So since we made a prototype or so, but because of time constraints and also how expensive the prototypes were to make, it was much more realistic to be able to do the simulation and then validate once or twice. And so we did that, and it was also great because we were able to do it on worst case scenario, and then even test in like simulate like regolith or something close to it, and what it would be like if it was impacting that. And yeah, and then just doing that, we were able to see like how the electronics inside the electronics are basically inside a casing and then inside of a foam, and we were able to see like how the vibrations would affect it, if the stresses would be on it, all that, and then also just verify that the electronics aren't going to like shear off the board or anything like that on impact under the worst case scenario. So all that really like helped us to really solidify our design and like get at least, maybe not like flight ready, but at least get us to the point where we're ready to test this. We believe once we make this prototype, like this will work, and this will work. So that was
perfect.
Super helpful.
Well, in a year, you did what most people do in like 10 years. That's amazing, the amount of work you guys did. That's great. And one of the things that was a surprise to me is how cold it is. I didn't realize it was that cold. So yeah, that's extreme thermal gradients, to say the least. So you know, you were new to Ansys. Tyler, of course, is an old hand at it, but when you were learning the tool, was there anything that was kind of a big surprise to you, that you kind of didn't expect in the simulation process, either a result or a process or anything like that?
I would say, I think it just really in general, like the process of like, I hadn't really done any like design work alongside simulation before. And I thought that was super interesting, just having like we don't have to build this and test it kind of thing. Like we don't have to like hope this is going to work, build it, and of course go back to the drawing board, do it again. I thought that was super cool that we could like CAD up some model, take that, throw it in there, you know, drop it a few times, run it through thermal simulation, see how it goes. And then, hey, this didn't work so well. This didn't work so well. We can go back, tweak that, maybe add some more insulation here, or a better conduction path or something like that, to make sure that it'll do that without having to actually make the physical model. I thought that was super useful and definitely a good application.
Good. How about you, Tyler? Any surprises in the process? Anything you guys discovered that you didn't expect?
One of the biggest surprises, I don't know if that's surprise, maybe challenge, it was kind of a surprise too, was how little information is actually known about some of these regions. So you know, like what the boundary conditions are, for example, right? So we know that the temperature, for the most part, I mean, it's, you know, generally known, but there's not a lot of detail about what the regolith or the soil is like on the moon. And when we asked, you know, they have samples from the Apollo missions, but those are from a totally different region of the moon. And so, and really no one knows. We talked to people at NASA, and there's experts in this, and they have, you know, they have good ideas, and they've got, you know, they have, you know, research and things like that. But at the end of the day, really no one knows until they go there and collect samples and bring it back. And so that was one of the biggest things, because, you know, with a simulation, you need to have good inputs in order to simulate it. And so, you know, we had to do a lot of research, and we had to do a lot of, you know, making engineering, you know, judgment, you know, choices, talking to experts, and, you know, looking at what other people do. So there was quite a bit of that with some of the, you know, boundary conditions, and that's not something we expected.
Yeah, that is a really good point. I mean, it's one of those things when you point it out, it's kind of obvious because nobody's been there, but I never thought about it before. Yeah. Well, we're going to learn a lot over the course of these Artemis missions, and very, very cool that you guys were able to be a part of it. I do want to come back and ask what's next in the project, but before I do that, one of the things that an opportunity for you as users, many of the developers do listen to this podcast. So, having used this on a real world project and under crunch and everything, is there any asks you have for software development at Ansys that can make your job better and easier?
I don't know, Connor, do you have any ideas?
I mean, I'm not. I feel like there's still a lot I have to learn in Ansys in general, but
Okay.
I don't know if they have it or not. But a version control system would be pretty helpful.
For your different models.
Yeah, like as you go through revisions and such, I think that would be a pretty helpful resource.
Yeah. So we're
I don't
working
imagine how
on that.
complicated people.
Yeah, we're definitely have a tool coming up for that. We should show it to you guys. It's pretty powerful, based on an open source tool, and we're just learning it ourselves and applying it with a couple of our customers, and we're finding that it's pretty good. So, yeah, we should definitely share that with you guys. Good to know. It is important especially when you're doing all these iterations. So yeah, my next question really is more about the project again. So you guys got your preliminary work done. What's the next step on the project?
So the way that these projects work is, NASA has kind of these roadmaps, and they kind of follow the advancement of the technology readiness level, or TRL. So they have like early TRL funding. They've got mid, late. And so what they kind of intend for you to do is when you win one of these, it's for a certain, you're developing the technology from, let's say, TRL 2 to 4, and then they expect you to then submit it to go from 4 to 6 or something like that. So ours, we went from basically concept to, which would be like 2 to 4, and we were very close to 5, but we didn't get to 5 yet. And so the next goal would be to submit the concept for follow-on funding opportunities that would allow the technology to be further developed, and that would be at ASU or with partners in the commercial space industry. However that would work, we'd follow on and submit. So as they get closer to the Artemis mission, they're trying to develop these technologies. So that's what we're doing right now. We're looking and identifying different calls to submit to for the project, and at the same time we are continuing development, kind of preparing it to go to TRL 5, and so doing things like Connor mentioned. We found some systems that need to be improved from the testing. We know there's certain things that we need to improve, and so the goal is to make those updates so that we're ready to advance it when the opportunity arises. So that's really the next step.
Very cool. Yeah, that's exciting. And what's the time frame on this? When's the first? I should know this. When they expect to do the first Artemis launch?
I think they just pushed it back. I think this year because of COVID. But I want to say, I'm kind of guessing too. So you could probably just Google this and see. I think it's 2023 maybe, or 20.
Oh,
yeah.
Soon.
Yeah.
Okay.
So the first one will go pretty soon.
Nice.
And that'll be an autonomous mission. It will not have a crew in that mission, and so those missions will go first, and then followed by the crewed mission at some point. So
very cool. That's exciting. I hope you guys get an opportunity to fly on it and do more simulation. I really appreciate it. It's been really interesting, and we'll make sure that we put in the show notes. You guys gave a really nice presentation at the Simulation World, so we'll definitely make sure there's a link to that so you can see for yourself what listeners can see for themselves what these guys did. And also, if you just Google ASU, and do you have a website that we can link to?
Yeah, it's the Luminosity Lab.
Okay.
Okay. I think.
Yeah. We'll put in the notes.
Yeah.
So we'll make sure we provide some links there. And then just see what happens. I'm excited that you guys got an opportunity to do this and learn so much, and I really appreciate you guys sharing it with us. So it's a great example of simulation-driven design in a pretty challenging environment. So.
Yeah, well, we appreciate you having us on the podcast. So it's been a lot of fun. We've gotten to do the Ansys Simulation World, and then this, and it's been great. So it's been a great experience.
Yeah, we love these great projects that you can talk about. This is the best part.
Yeah, not classified. So
yeah. Well, you guys enjoy your summer, and we hope to have you on again when you get to the next phase.
sounds great.
Thanks, guys. We'll talk to you soon.
Thanks, Eric.
Bye-bye.
Doesn't that sound like a cool program? I was really excited to learn more about it. And if you check out their presentation at simulationworld.com, as well as check out it's called the Luminosity Lab, one word, .com /projects, you'll be able to see actual pictures of the products. So do check that out and see the other things they're working on at the ASU Luminosity Lab. Great group of people and doing some pretty incredible stuff. So based on today's topic, for our commercial, I think it's a good time to discuss the Ansys academic and startup programs. Ansys academic software is available to teachers to incorporate into their curricula, students to utilize for assignments, and researchers to advance their projects. It includes free student software packages, as well as more capable tools for classrooms and R&D. If you think you need to use dumbed-down CAD-based tools or open-source kludge software, you don't. You can use Ansys. If your school doesn't have an Ansys academic agreement, have them reach out to their local Ansys reseller or search for the Ansys academic program on the Ansys website. And if you're a startup or know a startup, you should definitely check out the Ansys Startup Program. If you qualify, you can get access to the full Ansys set of products at a price that basically you can afford. And that price is based on where you are in your funding and revenue journey. And if you're in the Southwest, anywhere between, including Texas and all of California, so between those two states and including those two states, please reach out to PADT. If you join the startup program through us, you'll get access to our expert engineers, many of whom are on this podcast regularly. We do great co-marketing, and our producer, Trevor Rubinoff, is the person that coordinates that. And if you've ever seen some of the case studies we've done with some startups, that's the kind of thing you can expect from us. And you also get access to our expertise in startups. I myself spent a lot of time doing mentoring and helping with the local startup community here in Phoenix, as well as in some neighboring states. So we have a lot more to offer than other people when it comes to helping startups out. So again, if you're interested in either of those programs, please do reach out. They're fantastic and a great way to get access to Ansys software. In the world of news, let's start with the Ansys stock. I'm recording this on Sunday afternoon, May 16th, and Friday the Ansys stock closed at $325.47. So it's been languishing quite a bit since February. I shouldn't say quite a bit. I don't know what quite a bit is, but it's down since its all-time peak in February. And since our last episode, they did release their numbers for Q1 and had their investor call. So as usual, I'll give the generally accepted accounting principles, or GAAP numbers, or GAAP numbers. If you want the non-GAAP numbers, if you actually know the difference and care, please visit the investors.ansys.com site. There's all sorts of details and numbers there. And of course, anybody can visit that to get more details than what I'm presenting today. In the first quarter, revenue was $363.2 million, and that's a 19% growth versus last year. The profit margin on that was 13.8%, which is up from 11.2% for Q1 of last year. The annual contract value booked was $319 million, and their deferred revenue and backlog was an amazingly high $936.5 million. Cash at the company is at $987.89 million, so we can just call it $988 million. Yes, that's close to $1 billion in cash. This is a $75 million increase from this time last year. So even through all of the pandemic, they've actually grown their cash reserves a smidge. Long-term debt is about where it was. It's down slightly, a couple million. I think it was like $5 million from Q1 last year at $794 million. I suspect that the lower profit margin, and I don't know much about stocks and I don't understand why they do what they do, but the one thing that has changed is that the profit margin is now at 13.8%, and that is low compared to the historic level that Ansys has had. So who knows if that's why they're doing it, or if it's just that they all got on some Reddit feed and somebody said, don't buy Ansys. Who knows? I have no idea. But again, the company is very healthy, doing very well. regardless of where the stock price is, and lots of cash. And we hope to see some more new tools and maybe an acquisition or two in 2021. We'll see what the year brings, as we're 1/4 of the way through it. In Ansys news, there really is no Ansys news to report other than that financial report. We do have some PADT news to share. This past week, we announced that we are now a member of what is called the Hands-On Metrology family. This is a new product line for optical scanning brought out by the merger of Zeiss and GOM. And it basically allows us to combine those two very strong optical scanning tool sets into one product offering. So if you have any interest in adding handheld blue light or laser scanning, as well as optical CMM, reach out and we would love to talk to you about it. As you would expect, we know a lot about doing scanning and inspecting and reverse engineering and all that manufacturing and CAD type stuff. But in addition, with PADT, you also get the ability, a group of people that really understand how to connect scanning and simulation. So an added bonus there for those of you that are in the world of simulation. Publication-wise, in the Ansys blog, I only found one that I really liked that we're sharing right now. It's called Motorizing the Bike You Love with Bimodal and Ansys Simulation. And it's about using Ansys to design a motor that turns any bike into an e-bike, which I think is really a cool idea. I guess you attach it to the disc brakes, or you put a disc brake on it and you put a little motor on the disc brake. You have to check out the article if that's of interest to you. And of course, for those of us that do simulation, it's even more interesting because they talk about how they use MotorCAD to design that. So pretty cool stuff. On the PADT blog, we had 2 articles go out since our last recording. The first is a comparison of Ansys Fluent Meshing and Ansys Meshing for CFD by Daniel Chaparro. So, and it's just what the title says. He had a bunch of questions from people over and over again about, what's the difference between Ansys Fluent Meshing and the meshing in Ansys Meshing for CFD. So he went through and showed it. He wrote a really nice article that compares the two, strengths, weaknesses, different features. It's very comprehensive and a good tool for anybody doing CFD meshing. Good article for anybody doing CFD meshing. And then Joe Woodward also contributed a post called Ansys Mechanical Selection Information, even more useful than they thought. And it takes a deeper dive and looks at some of the useful tools in the selection information window. So this is a tool that allows you to create selection logic to break apart your model. And it does a lot more than just that. And he basically shares some of those things that it does. So check out both of those blog posts. In the world of upcoming events, we do have our next webinar on May 19th. It's Signal and Power Integrity Updates in Ansys 2021 R1. And as always, visit padtinc.com/events or go to brighttalk.com and search for PADT to find upcoming and past webinars. And that's pretty much it for events right now. We are looking at scheduling. In fact, we picked a date for our annual open house, which we had to cancel last year. Actually, we had to cancel 2 open houses. We usually do one for families, and then we do one for customers at the end of the year, families in the spring. And we canceled both of those last year, as you would expect. And we plan on having a significantly large open house. It's called Nerdtoberfest. We've done it for a couple years now. It's in October. And we're just in the planning stages, but we picked a time and a date for that. And look for a newsletter or this podcast to learn more if you're anywhere nearby. And we look forward to seeing those of you who can make it in person. So it's a long ways away, and we hope that things will be safe enough by then to have a big open house. That's pretty much it. So I want to thank everybody for listening once again. Don't forget to subscribe to our newsletter, where you can find out more information at www.padtinc.com/opt-in. And please spread the word about the podcast. And as always, don't hesitate to reach out. Thank you for listening. Thank you for joining us for the All Things Ansys podcast, episode 88. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.